the net ionic reaction, right? The net ionic reaction, lead, we're going to form lead sulfate is our product, right? So the net ionic reaction, we're going to remove the spectator ions. So it's just what's reacting, right? So lead, 2 lead are going to combine with 3 sulfates to make this lead 3 sulfate that's insoluble. Where's question 20? Oh, it's at the bottom here. All right, question 20. Acetylene, oxygen, how many grams of CO2? Okay, so this is a limiting reagent calculation like you'd expect to see on the exam, except for on the exam, right, on the exam, I would give you the molar masses to kind of expedite the problem. So are these masses the masses that everyone has, right? 51 grams of acetylene, 28 grams of O2. All right, perfect. So we're not going to get any arguing about who has what, right? 32 grams, 1 mole. 1 mole of acetylene, right? Carbon is 12, so that's 24, 25, 26 grams. So 51 divided by 26, right? I get 1.96 moles of acetylene, and 28 divided by 32, right? I get 0.875 moles of oxygen. We're not done there because we need to find out, right, how many grams of CO2. So we want to convert them both into CO2, into moles of CO2, and then we can find grams of CO2. So for every 2 acetylene, I make 4 oxygen. So 2 moles of acetylene down here, 4 moles of carbon dioxide up there. For oxygen, it's 5 to 4. So 5 moles of oxygen, 4 moles of CO2. All right, so you can just remember this when you're rich, wealthy doctors, and you can just make donations to Syracuse or something, I guess. All right, 0.875 times 4/5. All right, 0.7 moles of CO2. And then 1.96 times 4/2, right? And there we get 3.92 moles of CO2. So we found the limiting reagent, right? The limiting reagent is oxygen. When all the oxygen is consumed, I can only make 0.7 moles of carbon dioxide. So 0.7 moles of carbon dioxide. I know for every 1 mole of carbon dioxide, right? Look up the molar mass, it's 44 grams per mole. So 0.7 times 44, right? We're going to make something like 31 grams of CO2. I get 30.8 grams. So I'd round that up to 31 grams for question 20. Yeah, you could go one more step further. You could convert both of them. Right, we could convert both of them to grams of CO2. You're still going to get the same answer. The 700 came from right here, 0.875 moles of oxygen. I know for every 5 moles of oxygen, I make 4 moles of CO2. So 0.875 times 4/5 gave me 0.7. Right. 0.7, I'm multiplying by 44 to get the molar mass. And Nolan, we didn't need the 3.92 anymore. Right, because we figured out this is not the limiting reagent, so I'm done with this. I don't need to use this anymore because that doesn't limit my reaction. Oh yeah, people are having a hard time with this reaction, right? Or with question 21. Yeah, we'd only need the excess if we were asked about how much excess, right? All right, what do we have? All right, we've got 89.3 grams of HCl, right? We know 35, so 36.45 grams for one HCl, right? We get that from the periodic table, 89.3 divided by 36.45. I get 2.44 moles of HCl, right? 2.44. Are they asking for this in two significant figures? Anyone know how many moles of oxygen would be required for this reaction? A lot of you were answering one because there's the coefficient there. It's not, it's based on the chlorine, the HCl in this reaction. So it's not just, right, it's not just 1 mole. So we know for every, if I've got 2.4 moles of HCl, we know for every 4 moles of HCl, I'm going to need 1 mole of oxygen. So we divide by 4. And yeah, like was tossed in the chat there, yeah, we get like 0.612 moles of oxygen. All right, how much heat is released? And I think maybe the issue here is you're putting in a negative number, but it's because it's heat release, they're kind of already saying it's should be a negative number, so we're safe with like the absolute value of that heat. Right, so if I've got 2.44 moles of chlorine, we go to that thermochemical equation, and that tells us for every, 2.44 moles of HCl, we go to that thermochemical equation, right? For 4 moles of HCl, I'm going to release 202.4 kilojoules. And again, they kind of are already saying, just give us the absolute value. Yes, the exam will have much better. I know. Top Hat in this chapter is very inconsistent with, yes, Lexi, I agree. It's what we're talking about right now. I'm also frustrated in that between the homework questions, they go back and forth between wanting a negative, wanting a positive, and it just confuses everyone, and it shouldn't. So the exam will be much more straightforward, right? It'll be, if it's released, it's a negative. If it's absorbed, it should be a positive. So a matter of sign won't be an issue on the exam. So 2.44 times 202.4 divided by 4 is like 124 kilojoules. Yeah. Yeah, it's 124 kilojoules. And Will, like I was saying, they're looking for just a positive number because they've already said that it's heat released. So 124 positive should work for you. I think this is my last year using Top Hat. I think I'm going to go to a different platform next year. Yep. We had to use the coefficients, right? We had to use the stoichiometric coefficients because in this reaction, for every 4 moles of HCl, that is the energy I release. That's not the energy per mole of HCl. It's for every 4 moles of HCl. So, yeah, Will, you want to just do 124, like I said, like 7 times, 124 positive, right? And yeah, we needed to use the stoichiometric coefficients as well to convert from HCl to oxygen because they react in a 1-to-4 ratio. So we always need those stoichiometric coefficients. Yeah, because that's how we convert between different reactants. All right, I think the last one is 24 that people have been. Oh, okay. Yeah, 24 is going to be a significant figure issue as well, I bet, right? Um, right, we can do 23 and 24. That'll close us out anyways. And what the heck? It's already almost my bedtime. All right, 23. Let's see. We're looking for this reaction here. I want the iron 3 oxide on this side, and I want it as a reactant, and here it's in a product, right? So we want to flip this reaction. So if I flip that, I get the iron 3 oxide goes to 2 iron and 1.5 oxygen. And the delta H becomes a positive 824.2 kilojoules. Here I want aluminum as a reactant. Here I have aluminum as a reactant. I want aluminum as a reactant, so I can just use this equation as is, right? And that gives me 2 aluminum plus 1.5 oxygen goes to aluminum oxide, and that's negative 1675.7. Right, we add those together. Oxygen cancels out, and we're going to get our reaction. I add those together. And hopefully you're being serious and not sarcastic, right? Right, 3/2, 3 divided by 2 is 1.5. So I just wrote it as 1.5. All right, so 1675.7, 824.2. And I get a negative 851.5 kilojoules. Addition and subtraction. We have 1 decimal place. I need to have 1 decimal place in the final answer, right? So I should have 4 significant figures, 1 decimal place in that final answer, and it should be negative for question 23. Question 24 is a summation calculation. So delta H equals the sum of how many moles of delta H of my products minus the sum of how many moles and the delta H my reactants. All right, we're good with 23. Oh, it's Aaron. Aaron. Oh, my second favorite student in the 330 class. No, not the other one. AREN, not ERIN. All right. Delta H. Equals, let's see, products over reactants. So my products, I've got 2 of these. So 2 times 9.16 kilojoules plus nitrogen, which is 0. So that math is easy. Minus over here, I've got 4 of those. So 4 times 90.25, right, kilojoules plus, let's see, 2 of these. Yeah, I'm sorry I don't enunciate enough, I guess. 2 of these at 33.2 kilojoules. So let's see. That's 18.32 minus, let's see, 4 times 90.25 plus 2 times 33.2. So that's a minus 427.4. I subtract these two, right? 18.32 minus 427.4. And I get a delta H of minus 409.08. Again, addition and subtraction. I've got one decimal place here. I need to have one decimal place in the answer. So many of you that I've helped this week on this problem, right? Then the answer is negative 409.1 kilojoules. I need to have that decimal place there, right? So negative 4.091 e to the 2 kilojoules for question 24. And with that, I think we're done. Hess's law will be there. We did do a Hess's law question, right? Yep. Have a good one. Good luck on the exam. I'll see you all tomorrow or Thursday. And I'll get the recording probably posted. I don't know if I'll post it tonight or not, but I'll try to get it posted.